So today we are doing quadratic functions, right? We have done that before, that quadratic functions are the functions that have x to the power of 2 as their highest power, right? So these are quadratic functions. This is a quadratic equation, right? And when we model it on a graph, then it's called a quadratic function. And name of this shape is called a parabola, right? So it's called a parabola. Today we are going to learn a few vocabulary that we're going to use a lot when we graph this function, like vertex, axis of symmetry, y-intercept, x-intercepts, domain, and ranges. So I'm going to explain that today in this video. So our first bit is vertex, right? So vertex is the corner. You can call it as a corner or as a peak. So if you have a parabola which is opening down, the top bit here is the vertex, right? And if a parabola is opening up, then the bottom point here is the vertex, right? So in the curve that we have, in the graph that we have, if we see this point here is the peak, or is the dip, or is the point corner there, and here when we read the graph, the x-axis here is 1 and y is -9. So this vertex is 1 comma -9, right? So our vertex point here is 1 comma -9. That is the point, or the address, the coordinate of our parabola, right? Next point is axis of symmetry. So axis of symmetry is the vertical line, right? So it is a vertical line that passes through the vertex, and divides the parabola into two equal parts, right? So that is a line that when we divide, it will divide the parabola into exactly equal parts. So if we fold it, this curve, this side of the curve is going to overlap this side or this curve, right? So when you fold it, it's gonna overlap each other. And symmetry means the something that divides the shape into exactly two equal parts, right? So here, the most important thing is it is a vertical line in this case. So vertical line that passes through the vertex, right? Passes through the vertex. And when they are asking the axis of symmetry, they are asking the equation of that line. So equation of this line, equation of the black line that I have drawn, is x is equals to 1. Why is it x equals to 1? Because this is passing here, and at all points, no matter which one you go, the value of x stays 1, right? And the value, and it doesn't pass through y, right? So you can see this line is not passing through y-axis at all. It is parallel to y-axis, right? So that is why the equation of this line is x is equals to 1. And that is our axis of symmetry. X is equals to 1. Right? I hope this makes sense. Symmetry means the line that divides the parabola into two equal parts, and it passes through the vertex. Right? So in this case, it is passing through that point there. Cool. Next, we have y-intercept. So y-intercept is, let me clear this line a little bit. Y-intercept is when a line cuts through the y-axis. So when this curve is cutting the y-axis, it's here, right? So that point is your y-intercept. So y-intercept is at y is equals to -8, or if we label it, it will become x-axis is 0, y-axis is -8, right? on the y-intercept, your x value is always 0, right? So here at y-intercept, your x is always 0. So the coordinate is 0, comma, minus 8, right? Then you have x-intercepts. So in case of x-intercepts now, the y-axis is 0. So y is 0 in this case. We will find the x-intercept where the curve intersects the y-axis, right? Intersects the x-axis. So here it's that point which will be minus 2, comma 0, because this time the y value is 0, and 4, comma 0. So the two x-intercepts are minus 2, comma 0 and 4, comma 0. There are two x-intercepts there. Cool. I hope this makes sense. And when we are solving the questions, you will need to know all these things: vertices, axis of symmetry, y, and x-intercepts, right? Let's go to the next one, and the next one is domain. Domain means any x value for which the function is defined, right? So here, let's see for what values of x is this function defined, right? So that means which all x values are part of this curve. So let's start from 0. So at 0, there is an x value, like x is equals to 0 lies on the curve. X is equals to 1 here also, right? X is equals to 2, so that is going to be 2, comma something, but 3, 4, 5, 6, anything, all decimal numbers in there as well. All right. Similarly, on the negative side, if you go, so x is equals to -1 is also defined, -2, -3, -4, all over. We don't know where it stops, right? It keeps going. So all positive values and all negative values, for all positive x values and all positive negative values, the x is defined, right? So what we have to write is, and also for decimal values in between. So here, if we take 1.5, at 1.5, the function is defined. For even 2.5, here if we go 2.5, the function is defined. If you go for 4.5, it will be defined. 4.2, it will be defined, because at any point of x, you will find a curve passing through that point, right? So what we write here is that domain is x is defined for, or x can be any real value. X is any real value, right? So this is how you write a statement, but in mathematical way, we write it slightly different. We write it x belongs to, or you can say x is any real value. So this fancy R is the symbol for real values, right? So this thing here says x belongs to any real value. So any real value of x, you will find the curve passing through that point. The y value will vary, but the domain is that for all x values, the function is defined. All right, defining a function. What does a function defined means? We're going to do it in another video, right? So now the next topic is range. So range, so as we have done, domain is any x value for the quadratic, when the quadratic function is defined. Range is any y value, right? So here we will have to see which y values are the function defined, right? So the lowest y value that we have here is this vertex here, right? So now we know that any value here for the vertex, which is -9, so y value of -9 here, and anything above that, the function is defined. The quadratic function is defined for that, because the quadratic function covers those y values, but that is the minimum point of the quadratic function. So that means any value less than -9 any value less than -9 is not defined because the function doesn't cross through those points, right? It doesn't cover that points. So our range is anything which is greater than -9. So how do we write that? Is that any value of y greater than or equals to -9 is the range of that quadratic function, or of this quadratic function in this case. All right. And the last bit that we have to cover is minimum and maximum value. All right. So depending on if your parabola is opening up or is it opening down, you will have only one of the points. You will either have minimum, which is when it is opening upwards, you have a minimum value. And if it is opening downwards, you will have a maximum value, right? You can have only one value in the quadratic function. In this case, in our example here, we have the minimum value, right? Another important thing to understand is that because it's only one maximum or min, why? Because here if we see this curve, when it goes upwards, it can go as high as it wants, right? But the only restriction is it can go lower to only that certain point, right? Similarly, when it is open downwards, it can go as low as it wants. It can just keep going on and on and on, but it can go as high as that point only, right? And when they are asking us the value of something, that value means the y-intercept, right? So value means the y value of it, not y-intercept, sorry, is the y value, right? Why is that? Because that is the function. Y is equals to something. So they are asking for the y value of that quadratic function, right? So in this case, in our example, the lowest where the parabola can go, the lowest that the parabola can go is -9, right? So our y value, or our minimum in this case, our minimum value is -9, right? And there is no maximum value because this curve can go as high as it wants, right? I hope this makes sense. This is the basic introduction of what a curve, when you look at a parabolic curve, what information can you get out of it just by looking at it, right? So that's a very important concept. Make sure you watch it again if you need clarity on any of the subjects.